So there are three basic components of the way we do Agile development at East Agile. So the first one is that we do paired programming. So this means that you literally have two software developers as the minimum team size, and it could be multiples of two. 6 is considered a very large team. And those two developers sit at a desk together. They share a single computer or set of computers. They have two keyboards and two mice, both connected to the same machine, and their eyes are focused on the same lines of code as they do development. And basically the premise for this is that if code review is a good thing, well, why not have constant code review? If collaboration is a good thing, why not have constant collaboration? It means that you have fewer situations where one person has an idea that seemed pretty good and they didn't have a chance to validate it with anyone else, and they ran with it only to discover later that there was actually another better idea that was much more effective. So you have fewer false starts, fewer misdirections, better architecture at every tiny micro step of the development process, and that saves enormous amounts of time. Also, fewer defects, because there's just one more set of eyes to think about, is that really the best way to do it? And catching mistakes. And then it goes more beyond just the code quality. This also means that the project can scale up faster. So for instance, if you want to move from 2 to 6 people overnight, it's a lot easier to go from 2 people to, say, 4 people, because you can take one pair of developers, split them up, and bring in 2 other people, and now you've got 4 people. And yet each of those 2 teams has already one person who may have had months of experience in the project, deep legacy understanding, and then yet another person to work with to add value to the project as well. It can also help when you want to do a shift to different technology focuses. So for instance, if you wanted to, say, you're building a web application, and now it's time to build the iOS or the Android version of that application. You can bring in an iOS developer and swap them into a pair. And now you're developing the iOS application, but you still have someone involved in that pair who has deep legacy knowledge of the code as it's been developed so far. So you've got this perfect combination of a new technology skill and the understanding of the entire system. It also helps, for instance, in situations where someone quits. That doesn't prevent software from continuing to develop. If someone needs to, gets hit by a bus, so to speak, the bus count is very low on paired programming. So when you want low risk of anything actually coming into effect that might stop development, paired programming really reduces risk. And so it's really great for reliability from that perspective as well. And then also, it just means that every piece of code is understandable and accessible by more than one person, which means that the code tends to be more portable, because at least 2 people had to understand it, at least 2 people had to agree that it was the right way to go. So when you're looking at the code later, or someone else is looking at the code later, it's more likely to be less idiosyncratic and more likely to follow standards and be accessible. So a second really important part about the way we do software development is that we do test-driven development and behavior-driven development. So test-driven development means that, well, let's back off a sec. If you're going to do testing of your code, write automated tests of your code, well, first of all, if you're going to write a test, it's assuming that you need to do that, that's a certain amount of work you need to do. Now, traditionally, this is done after you've written the code. You write some code and then you write a test. Well, this is kind of wasteful, because it's much better to write the tests before you write the code. Because, well, for 2 reasons. First of all, the actual act of thinking about how do I know if this code works helps you to actually write the code itself. So knowing how to test if it works helps you to write the code and so if you write the test first, you're better prepared to write the actual code itself, and with fewer mistakes in terms of going in the wrong direction. So by simply moving the test development process from after the code is written to before the code is written, the actual code development time becomes faster. But there's also another benefit to it as well. Because you write a test before you write the code. So you write the test and the test fails because there's no code. So then you write the code to make the test pass. But if you find, for instance, in the process of writing your code, that your test starts to fail, that gives you a signal that maybe you're making a mistake. Either the test isn't good, so it helps you to make sure the test works, or the code has a problem, and it helps you to identify at an early stage that you're going in the wrong direction in terms of software development. And so instead of, for instance, spending 3-4 hours writing some code and then doing some tests and then finding that, oh no, actually something you didn't really notice was wrong, you spend maybe 15 minutes or half an hour writing code and the test fail, sending you a signal, hey, wait a second, you're missing something. And so you save those hours of time. So given that you're going to do testing anyway, writing the test first makes the whole development process faster. And even if you thought, oh, well, you know, skipping the tests might speed up development, actually, skipping the tests, while you might spend half the time writing the test and half the time writing the code. By writing the tests and having tests, you will often save time, or at least save much of the time of test writing by being able to develop code faster and avoid mistakes you wouldn't have caught otherwise. The real benefit of this doesn't come in the first few weeks, although there can be some benefits. The real benefits happen when you've built a successful business, when perhaps 6 months down the line or a year down the line, you've got a massive code base, a very complicated system. And if you don't have tests, you end up with really fragile code. You want to change one thing, something else breaks, but you didn't even anticipate it. You didn't know you caused that effect. It means that it's very hard for you to make even small changes. And so you go from this, you go from a point of rapid change to slower and slower and slower change to the point where you reach a point where it's very hard to pivot your business. It's very hard to adapt to changing competitive circumstances. You end up in a situation where you have to hire a large team of developers just because it's so complicated to make change. You have to have a big QA team. You have to do so many tests and things to make change because there's no test coverage. It also means that you can end up with dependencies on the original developers. Only the original handful of developers understand the massive complexity of a system that you have, and you become dependent on those people. And whether those people are founders who are now ready to move on to other roles in the firm, or an outside firm like ours, or developers who, you know, now are critical to your success and major failure points if they were to leave, you know, these are all things that you want to avoid. And so having test coverage can help keep your later team size down, can help your business continue to be just as agile a year from now as it is in the first day. And it can be incredibly cost-saving over the course of not the long run, but a medium run. And so most professional developers who've been around and seen it done the wrong way and seen failure realize that doing test-driven development is a key to making a business that's going to be able to be competitive against a changing landscape. Another important theme with agile development is confidence. Confidence comes from TDD and BDD. When you have solid test coverage, developers feel confident that they can move forward with new features, they can experiment, they don't need to feel fear that they may have unexpected consequences from their actions. Confidence allows your team to work rapidly and innovatively. Indiegogo was another one of our clients. We sent developers from East Agile on sites there to train their development team in agile processes, specifically writing really good tests, enhancing test coverage, and understanding the benefits of paired programming. Now, test-driven development using tools like RSpec is very good at testing particular features in a way that is very easy for software developers to understand. And by the way, by having test coverage like this, it avoids much of a need for documentation, because the tests themselves can be read and they make assertions of how the application works. And they're not just assertions, but they're proven assertions, because you can see that the tests pass. Or you can see things that, tests that fail, which show that that's the way the application should work, but doesn't quite do it right at the moment. But, beyond TDD and RSpec, we also use behavior-driven development and tools like Cucumber to implement it. And this is a much higher level type of test coverage. This is looking at behaviors. So things like, I should be able to log in and recover my password. And behavior-driven development has a certain sort of grammar to it that is written in basically plain English, that's converted automatically into tests. And so this makes for much closer to the ideal I just described of tests as documentation. So you'll have a whole bunch of English language statements. Say, as a user, I should be able to recover my password. For instance, might be a test, a behavior that you could write for an application. And this wording could be written by a product owner who has no programming ability. It could be written by a lawyer who wants to ensure certain regulatory requirements is met. Before a user can execute a trade, they must agree to contract 425B. And you can have this as be a behavior, and you can ultimately, after an application has become complex, have a large set of behaviors, all of which can be read by anyone, all of which are far better than documentation. With documentation, it tends to be either it either ends up being a specification, this is how the application should work, and the reality may be that the developers didn't quite implement it that way. So it becomes like a dream of how it should work, or one version of how reality should look, but it ends up not being how things actually work. Or it might actually be a description of how the system really did work at a certain point in time. But the day after, you can't be sure that something hasn't changed, because almost every application is changing all the time. So any documentation is obsolete almost immediately. And if you really want to ensure that it isn't obsolete, you have to spend immense effort documenting your applications on a continuous basis. And there's always the risk that it's not quite described the way it really does work. So it becomes a burden, it becomes a barrier to development, a barrier to release, and still a risk that it's not quite right. But with behavior-driven development, written in Cucumber in English, you can read this and go even deeper and read the RSpec. And it's not just, an expectation of how the app should work. It's not just a description of how the app worked at some point in time. It's a set of tests that really are proven assertions that the app really does work that way. And when you do see a failure, it's also interesting, because that's describing a behavior that the application should have, but is not implemented properly yet. And so, while this allows you as a startup to be very agile in terms of future developments, because you can bring in new people, they can quickly understand how things are working, they can write code quickly, despite the massive complexity of your application, they can understand if things are broken, so they can be experimental, they can come in without complete knowledge, you can feel that the code can be transported from one development firm to another, or one development team to another. You have a lot of confidence that you're not being locked into stuff and that you can move quickly. And that's very powerful in a very dynamic, rapidly changing competitive environment. But, you know, for larger enterprise, regulatory, especially industries, it's also extraordinarily important. If you need to be able to prove, you know, that you made all efforts and that your application actually does implement special regulatory needs, then these tests show an assertion that it always does this and that changes in the code haven't changed that behavior. And it allows your growing team of non-developers to participate, whether they be marketing people, ensuring that certain treatments of customers are implemented properly, or lawyers making sure that certain regulatory requirements are implemented properly, or domain specialists such as engineers or doctors making sure that certain, you know, steps have been taken when interacting with a customer. All of these things they can participate in. And it, you know, even people who have specialties that aren't necessarily, say, software development at, say, the user interface level or at the database level can all participate in creating stories without understanding all of the code. So it's very powerful for both dynamic and for mission-critical industries. Now, a third part of the agile development process that's really important that we've alluded to in these other two things is that we don't have requirements. We don't need requirements. So very frequently, the development process can start with weeks or even months of work spent creating very detailed requirement documents that basically define at a micro level everything that needs to be done. And then only after that's done does the development process begin. Often this puts such a lag in development that by the time development starts, some of those requirements might be out of date. And it also means that there's a big competitive disadvantage compared with others who simply just start implementing and releasing code right away. With agile development, we work towards making sure that releasing an application to the public is a business decision and not an engineering decision. So what that means in practice is that at the end of each week, at the end of an iteration that's about a week long, the code has been implemented to a state where it could be released. It's not a big, long race towards a certain point at the end, and only then can you release. You can choose to release every week with new features that have been added that week, and that's a business decision. And that's very powerful. So really you can come up with a minimal viable product, a very basic implementation of your business requirements in perhaps a fraction of the time for the total development. And so that means you can quickly get some feedback on business users. You can get buy-in from people who are financing the application. You can get feedback from customers. You get all of this stuff early, and you may discover that there are changes that you want to make. And the whole process is resilient to change. You can change your mind every single week, even every day, about what you want to have done. And this means that when you finish doing an application using agile development practices, you don't just have everything that was asked for. You actually have everything that you need, which may be very different by the time you get to the end of the process. Swink was another one of our clients. They came to us at a stage when it was just one person and with an idea, video for sporting events, video for athletes, amateur athletes to track their plays in sport. And they didn't have a lot of money, but we were able to build an MVP for them in just several weeks. Then with that MVP, the Swink founder was able to meet up with numerous investors and eventually land quite an important investor, DFJ Frontier in LA, and raised quite a lot of funding and went on to build a very substantial system that exists to this day. So we usually work in iterations, as I've said, and those iterations are blocks of development that typically last about a week. They may start in the middle of one week and end in the middle of the other week. And by the way, releasing on, say, a Friday is not a good idea, because should anything go wrong, you've got the whole weekend with no people working on it. So better to release in the middle of the week. And so iterative development usually starts, if you're building a new application, even if you know you want to build the whole thing, with first doing the things that add the greatest business value or have the greatest risk. You do those first, so that instead of having, often when you leave a team to work on stuff and do whatever they want when they want it, they might do the fun stuff first, or the easy stuff first to show quick progress. But we actually try to do the opposite. We do the hard stuff, the stuff that's most likely to fail, the stuff that adds the greatest business value but may also be, the most challenging. We do all of that first in the first iterations. And then with each subsequent iteration, we do things that have decreasing business value, because the most important stuff has already been done. So what this means is that early on, all of the challenges are faced, and then as a development progresses, the level of uncertainty diminishes, so that you might actually find that you can release a minimal viable product in maybe a third of the time it would take to produce the entire product. And then with each subsequent week, you're getting more and more done. And as you get towards the end of a deadline, for example, the only things that haven't been done are things that are easy and not very important, and don't add much business value. So the level of risk towards an end of a project diminishes. The cost of something unexpected happens diminishes, and in fact, the point that you might say you were done ends up being the point where waiting an extra week just isn't worth the extra value, and then you're done. And anyway, so iterative development reduces risk in the entire development process and delivers results really quickly and allows changes in direction. So those are key things about the way East Agile has best practices in terms of software development.